It was a sunny day when suddenly the skies over the United States were ablaze. A violent solar storm, more powerful than anything mankind had ever experienced, was hurtling towards our planet. That was in 1859, and if experts are to be believed, the next violent solar storm is imminent. We have to ask ourselves now, could the sun destroy the Earth in 2025? It sounds almost too crazy to be true, but we must expect chaos that the old world order will not survive. In 1859, people didn't even know what was happening at first. They only perceived the unusual play of light, which was comparable to enormous northern lights. The fire in the sky was caused by myriads of charged particles rushing towards the Earth with incredible speed. The sky, which normally glows in soft shades of blue and white, became a vivid canvas of red, green, and purple. At first, it was as if a painter had conjured a masterpiece on the sky with vibrant colors. In the southern states of the US, prospectors looking for riches in the midday heat were surprised by this unexpected light show. Some thought morning had dawned again in a surreal explosion of color. Others believed the sky was on fire and a great fire had begun. Panic broke out in the cities, and the streets filled with people looking upward. Some stretched their hands to the sky, thinking that divine Armageddon had come upon the globe. People experienced awe and pure fear. The technology of the time was not prepared for such a phenomenon. Telegraph lines sparkled and crackled as if they suddenly took on a life of their own. Some telegraph stations even reported sparks shooting out of their equipment as if possessed by an invisible spirit. Messages were interrupted and communication between cities came to a complete halt. But despite the initial fear and confusion, people soon found comfort in the beauty of this natural phenomenon. Families gathered on their porches, children pointed to the sky with wondering eyes, and couples held hands as they watched the celestial spectacle. It became a moment of pause, reflection, and fellowship. The spectacle lasted for just under 5 days, from August 28th to September 2nd, 1859, and then the storm subsided. The Carrington Event, or the day the sky was on fire. When the storm subsided and the sky returned to its normal blue, people were reassured. They had realized how small they were compared to the vast universe and how wonderful and unpredictable nature can be. A British astronomer named Richard Carrington had observed a coronal mass ejection from the sun shortly before the event and had quite correctly linked this event to the violent geomagnetic storm. However, since communication had completely broken down regionally, it took a while for everyone to know what was really behind the storm. In science, the geomagnetic storm of 1859 is now known as the Carrington Event. Among ordinary people, stories about the day the sky was on fire were passed down from generation to generation. From a poetic or metaphysical standpoint, the play of colors was a living testament to the power and beauty of our sun. To this day, the violent solar storm reminds us that despite all our technology and knowledge, we are still children of the universe, marveling and awestruck at the wonders it has to offer. The Carrington Event was almost 200 years ago. None of us has experienced a comparable solar storm. But that could soon change. It's only a matter of time. The next solar storm will be devastating. Solar storms are caused by complex magnetic activity on the surface of the sun, especially sunspots and solar flares. When these magnetic energies are released, they hurl charged particles into space. This phenomenon is called coronal mass ejection, or CME for short. These charged particle streams of electrons and protons hurtle through space at tremendous speeds and then strike the Earth's magnetic field. Normally, the Earth's magnetic field intercepts most of the particles. In fact, our planet has quite a sophisticated system for dealing with these particle bombardments. The magnetic field intercepts the currents and directs them along the magnetic field lines to the polar regions. This process is responsible for the beautiful phenomenon of the auroras, or aurora borealis in the north, and aurora australis in the south. The particles are moved back and forth in a kind of magnetic bubble until they have lost power and become harmless. However, our magnetic shield can only handle a certain amount of particles. If there are more, they slip through the protective mechanism and enter lower layers of the Earth's atmosphere. Humans don't mind the particles quite as much, though experts and biomedical scientists suggest that about 75% of the population is able to physically feel solar storms. Most, however, don't even notice. Much worse is the effect on electronic systems, satellites, and communication networks. We now live in a world where almost nothing works without electricity and electrically based communications. Scientists monitor with satellites like the Solar Dynamics Observatory or the Solar and Heliospheric Observatory. Around the clock, these facilities observe the sun's activity and collect data on its activities. They capture images of the Earth's surface at different wavelengths, allowing them to identify sunspots, solar flares, and coronal mass ejections. By analyzing this data, scientists can make predictions about possible solar storms. Practically, in the past, the sun's activities have been shown to follow certain cycles. The eruptions and storms thus became predictable. However, despite these advanced technologies and methods, predictions about solar storms are not always accurate. The sun remains an extremely complex and dynamic system, and many of its processes are not yet fully understood. In addition, solar events can evolve rapidly and unexpectedly. Another factor is the time it takes for a coronal mass ejection to reach Earth, which can vary. This makes it difficult to predict the exact timing and intensity of an impending geomagnetic storm. The Carrington event of 1859 was likely an exceptional storm. Since we lack comparative data, it's difficult, if not impossible, to predict when such an unusual storm will occur again. The only certainty is that it will come, and possibly as early as 2025. The global catastrophe is imminent. In our modern world, we depend on technology more than ever. Satellites circle overhead, providing us with communications, navigation, and weather data. The internet connects continents and cultures in real time. Our infrastructure, from power grids to organizational and financial systems, is digitized and interconnected. These advances have left us vulnerable on a side that no one really wants to acknowledge. Everyone knows the devastating storm is coming, but everyone also hopes our civilization will weather it. We can ask ourselves why we do not prepare or protect ourselves better. This question is easily answered. We can't go back. Our society, the economy, research, all areas of our life are moving unchangeably towards digitization and mechanization. Be aware, when the next devastating geomagnetic storm comes, our entire power supply could collapse for hours, or possibly days. Telecommunications would be paralyzed. There would be no TV and internet, and all your data carriers like hard disk or cell phone memory could be deleted or destroyed forever. Imagine a major city without power, communications, or transportation. Planes confused without technical navigation, trying to stay on course and avoid collisions. Electric lights could be gone. Power-operated security doors of banks or prisons could fail, and ATMs could go on strike. That's just a very small part of the incredible scenario we face. The economic, social, and political impact would be enormous. When is the storm coming? We are currently in a special solar cycle that began in 2019 and is now peaking. This cycle has already shown an increase in solar activity. In 2021, the number of magnetic storms tripled, again indicating increased solar activity. This should serve as a wake-up call for all of us. It's a clear sign that we need to prepare for potentially stronger and more frequent solar events in the years ahead. One particularly disturbing event occurred in 2012, when a rare massive solar eruption hurled massive streams of particles through space, and they narrowly missed Earth. Had this outburst hit our planet, the effects would have been catastrophic. Astronomers who observed this event had to think inevitably of the prophecy of the Maya, which predicted the end of the world for the year 2012. Our world was spared and continues to exist as usual. The only question is how long this will last. Some experts see the next enormous ejection coming in the year 2025. If it hits the Earth, we must prepare for an enormous chaos, and we have hardly the possibilities to protect ourselves. The emergency plan for 2025. The 2012 event should send us a clear message. We must be prepared. It's imperative that we invest in technologies that are more resilient to solar disruptions, and we must develop contingency plans to respond to such events. While we enjoy the benefits of our interconnected world, we must remember that we are still subject to the vagaries of the universe. We have no means of intercepting or redirecting the particle streams. Neither can we control the activities of the sun. All we have left are backup measures here on Earth. But how to implement an emergency plan when cell phones and telephones no longer work and the streets remain dark at night? You can already see that the emergency plans may be pure utopia and will not help us much in the case of an emergency. We humans remain vulnerable on our planet despite all our technology and early warning systems. Solar storms, supervolcanoes, tsunamis, and other disasters of global proportions remind us again and again that we are neither masters of the planet nor our solar system. Solar storms can also help. Despite the looming danger posed by solar storms, there are also silver linings on the horizon. One unexpected benefit of the current significant increase in solar activity is its potential ability to reduce the space debris clogging our orbit. Yeah, you heard right. Solar storms can clean up space and remove trash consisting of old satellites, rocket stages, and other debris. Experts are already saying that we humans are now cluttering up our planet in space, much like we do on the surface. The ISS already has to be careful, because almost every day there is a piece of junk in the way that could disrupt or severely damage the delicate station. Each of these pieces of debris can travel at high speeds and has the potential to cause significant damage. Not only is the space station affected, but satellites and future spacecraft traveling to the moon or Mars will also be affected. Now, I'm sure you want to know how the sun will clean it up. It's simple. Increased solar activity can cause the Earth's upper atmosphere to expand. When this happens, atmospheric drag increases for objects in low Earth orbits. This in turn causes space debris to slow down and eventually sink into the denser layers of the atmosphere, where it burns up. This natural cleaning process could help reduce the risk of collisions in space and make the orbit around our planet cleaner and safer. Subscribe now because the best videos are yet to come.